Assalamualaikum, we are Group Soon and today we are presenting our Building Energy Audit system developed in C programming. My task was data acquisition. I implemented a function that uses nested loop to collect engineering data for 10 diverse building entities such as lift and pumps. As required, I stored these 3 parameters per entity such as HP, voltage and current into a 2D array using pass by reference to ensure data integrity.
So I handle the engineering calculation phase. My function processes the raw data from the 2D array and apply the power formula. The power is power equal to voltage time current. These calculated results are then stored in a separate 1D array for further analysis.
I go for the peak performance analysis. My role was to identify the critical load in the building. I developed a function that can scan the power array to find the maximum critical value. It returns the peak IDX, which allows our system to pinpoint exactly which piece of equipment has the highest energy consumption.
So next is I developed the safety logic using an if-else structure within a loop. The program compares each unit's power against our safety limit of 5000 watts. If a unit exceeds this threshold, it is immediately flagged as unsafe in our status array.
Finally, I designed the technical report. I use proper formatting codes like %-15s and %.4f to generate a professional table. These ensure engineering precision in our output. As you can see in our execution, the program clearly identifies the critical load and provides a full safety summary. Conclusion, a key concept we applied was passing through the array to our report function, allowing us to display the original input spec alongside our calculated metrics. This concludes our presentation. Thank you.
Now, let's see the system in action. I will execute the program and input the actual engineering data for our 10 electric equipment building entities. First, I am entering the passenger lift with an HP rating of 10, voltage of 450 volt and current of 30.5 ampere. Second is the water pump with an HP of 3.0, voltage of 240 volts and 8 ampere. And third, our most heavy duty entity, the main chiller with an HP rating of 25, voltage of 450 volt and current of 35 ampere. The system has now generated the engineering log report. Every row display the calculated power in watts, format precisely to 4 decimal places. Take a look at the main chiller. The function calculator is power based on the 450 volt and 35 ampere input. This high voltage is a direct result of the power calculation logic. Because the main chiller exceeds our safety limit of 5000 watts, it is automatically flagged as unsafe. The passenger lift and water pump remain within the safe operating range. Finally, at the bottom of the report, the system identified the main chiller as the critical entity for recording the highest power consumption in this entire audit. That's all. Thank you.